So, hello everybody. Today is September 11, 2025, and welcome to KCP community meeting. And today I will be your host. And as any other CNCF hosted projects, KCP meetings and KCP is governed by CNCF code of conduct, which boils down, let's be excellent to each other. And we have an agenda document, which I'm gonna share in a second on my screen. And I'm pasting this in a channel now. So if you are in a document, feel free to add yourself if you want to in an attendance list. Who's there? And before we jump to the agenda items, I just want to give a opportunity to introduce if you are new to this community, if you just joined. So, and if you want to introduce yourself, this is your time. Going once, going twice. Cool. Okay, so let me share my screen. Cool. Do you see my screen?
Yes.
So first item is mine, which, yeah, and I don't share this. Okay, so if you click on the link in the description, you will get redirected to the Slack conversation where we've been discussing this, and it's more in general of agreeing a direction where we want to take it. If we agree on this, we basically create a follow-up issues and we find somebody to work on those items. So long story short is, recently we introduced this ability to lifecycle API exports when they are instantiated part of workspace type. So for those who don't know, basically you can create this as a semi-template of how your workspaces could look like when they are created from the workspace type. And the problem there with limitation is that currently it's life cycles the API exports itself, but not the export content. And by content, I mean if one would go and deprecate an API from the existing export or add additional permission claims, they are not lifecycled. And this was more of the open question, should it be lifecycled? Is this part of the workspace type lifecycle, or should we just say, no, it's not? And I'm just wondering, do people have any opinions on that? And I'm very much cautious that it's hard to absorb the context. So what I encourage is to go to the Slack thread and basically express your views there. And I think it's the easiest way to take it offline, basically. And I just noticed in the chat, you don't have edit access. Yes, you need to join our mailing list to get an access, basically, to be added. If you just post your handler in a chat, I will add you manually now. And for that, for next time, you just need to join basically a Google group. So that's the first item. Robert, yours is the next one?
Yes.
Do you want to screen, or are you gonna talk through this, or what is it?
I can share. There is stuff to share.
Yeah, because I know what's this about, but I suspect other people might not. So if you could give a brief introduction to.
Yeah. Okay, can you see?
Yes.
I think so. Okay, cool. So virtual resources, what they are. So virtual and resource, those are the two keywords. So in this diagram, we have an API resource schema.
You're showing your code editor, not diagram.
Oh no.
We see basically the Golang spec. Nope, still no. Maybe just me. Hello?
I also see only the editor.
Okay.
Good morning.
Morning. Robert, we can hear you if you're talking. You're on mute.
Okay, sorry, I think I had some connection problems. 1-2-1-2, maybe it's...
Yeah, we can hear you now.
Okay. Okay, second attempt.
Mhm.
Hopefully you can see my diagram.
Yeah.
Excellent. So, virtual resources. So here we see normal resources. What I mean by that is that we have a resource schema of a cowboy definition, which we then export into two workspaces. And we do that by creating a binding for the export. And what happens underneath is that the API binding reconciler will create a CRD from that schema. And the CRD is not really visible from user's perspective, but under the hood, that's how it actually works. And inside the workspace, you can create, after successful binding, you can create your resources, your objects of that schema. And those, so this cowboy and this cowboy, they're completely disjoint. They just share the same schema, but they are originating from two different CRDs, and they are separate in etcd at least. Now, what a cached resource is, and then I will go into what a virtual resource is later. So similar scenario, we have an API binding to that export. We create a bunch of cowboys, and we create a cached resource whose reconciler is watching those GVRs for cowboys, and then it replicates those objects to cache. And then we can create an API export with something called virtual resource. So virtual means that the object that will appear here after binding to that export is not really there. It doesn't consume bytes in etcd. It's virtual, so that means it's actually coming from somewhere else, and that somewhere else is, in this case, replication workspace, a virtual workspace. You can see that in the code.
Yeah. And while you might, it's read-only. So
it's
basically,
read-only,
yeah. So the idea is, let's say you want to propagate something like you have an API for virtual machines, and you want to propagate virtual machine types to be referred in your API. Yeah.
Exactly. So this is how you would do that. So those are two resources that we are exporting. So one is normal schema CRD backed, or maybe we can skip the CRD part, but it's backed by a schema. Yes, somebody has a question. I can see.
No, I'm just
Sorry.
keep continuing.
But if anyone has something to say or ask, just go ahead, interrupt whenever. So this resource we expose from a schema, and the CPU flavors is exposed from a virtual storage type. And here we have a cached resource endpoint slice, which looks like this. There is let's say a set of URL addresses that target a virtual workspace, and what happens during binding is that the reconciler for API bindings will get the correct URL for that shard. So we are in shard number 3, so it will get the first URL from that list, and we'll go get the discovery and resource data from here. And what this means, practically speaking, is that for the workspace where API binding lives, we don't really need a schema object. For the case of normal resources, we do, because we need to create, like we've seen here, create a or the API binding controller is to create the CRD, and then you can create your objects. But since the virtual resources that are bound to this workspace are actually coming from a completely different Kubernetes endpoint, we don't need a specific schema to work with. We can just get all open API and discovery and resources. All of it comes from here. So that's the general idea. Where the problem actually comes in later is that the group version resource name of a type plus all of its so a type is described by those attributes. So we have group, kind, resource, singular, resource name, and list kind, and there is also short names. So for all of those attributes that describe a type, all of them need to be unique within a workspace.
Right.
And now, yeah.
No, continue.
And now, normally what happens when we do an API binding like this is the reconciler for binding will check that the incoming schema that we are binding is in all of those aspects, in all of those attributes, unique for that workspace. And since the schema, the API resource schema object is immutable. This will never change during the lifetime of that binding. So you can, yeah, you can basically be sure that once you check for uniqueness, you are fine, and you can continue with other bindings in the future and still be protected by the first check during that time when you made the binding. But this doesn't really apply for cases where your schema and discovery type information comes from a dynamic place like a virtual workspace. Imagine a scenario that your cached resource, instead of being backed by a resource schema, API export, API binding, it instead is backed by a CRD, by an actual CRD that lives that you as a provider created, and this will keep working. Like it will be teleported to the cache as normal, and it will work until the very point when you, as a provider of that CRD, decides to, for example, add a short name for your type. Because let's say you are a developer who don't know any better and you've forgotten to define it when you first created the CRD, and now you are adding a short name of CM because why not?
But you're adding this in the original source workspace, right?
You are adding this into the CRD. That is the origin of the schema of those objects that are then pushed to cache, and then so this is the writing part, and the reading part is then from binding to the virtual workspace and finding out that we have a new short name that is now in that is now aliasing the other CM, which is the config map. And that's something we don't want to do. So in normal circumstances, this would result in this case when we have just API resource schema and CRDs and all of that. This would result in a binding error. I think one of the conditions would be marked as false. But here, since we have a dynamic environment, simply because of the fact that we are sourcing data from a virtual workspace, we don't have any immutability guarantees. So we can start colliding and aliasing types that are currently defined in the workspace. So, are there any questions up until this point? If not,
Just was wondering, like, it's a legit problem. Like, I was wondering, do you have a proposed solutions to how we can?
So there are, I would say, at least three actually. I should have written down before. So the first and the least reliable one would be to fix
That's a good start already.
Yeah. Would be on the provider side. So in the replication virtual workspace, when we are queried for data from a consumer, meaning from a workspace where there is an API binding to cached resource and endpoint slice, we could check that there are no conflicts for each request, and I don't know, do like 404 or something if there are. I particularly don't like this approach because this relies on each virtual workspace implementation
Yeah.
to do this check. And that's why I said it's unreliable. That like we shouldn't assume that the implementation of this is correct and then break all consumers of that API export if it's not, in fact. The second approach would be to add an additional field to boundary API resource. So we are in API binding definition. So we have API bind. No, we have API binding. We go to status. We have bound API resource slice, which originally had this state of things. A proposal to get rid of conflicts could look like so. So, as I mentioned before, in virtual resources, we don't really need schema from here. So this is unnecessary. What we do need, though, is those names that we attribute to a type. And those must never change after we have bound that virtual resource to workspace. If they do, and how do we know that they have changed? So in the status field of this bound API resource struct, we would mark down whatever we have found out during discovery phase of when we are binding this virtual resource. And then I guess on each request, we would have to check that we are not deviating from those agreed names. And if we are, then fail.
Okay, that's quite intrusive one.
It is. And then
And
the
what would be
least
the third one?
intrusive is to keep this. And we would leave all the binding logic that we currently have as is, meaning that there would be a requirement for if we are exporting a virtual resource, there would be a requirement for such a resource to also have a schema somehow provided. This is the provider would be responsible for that, and then
so in a way,
as normal.
if you go to the left now on your screen, like where you painted this one, in this case where this guy is here, despite the fact you use CRD, you would have to have API resource schema available.
And we do have that. We do have that because so so we are in cached resource. We have cached resource status, and a couple of days ago, I've added this change where we describe the cached resource schema source, and it can be either an API resource schema or a CRD. And in both cases, the reconciler for cached resources will clone the original schema, whatever it is. It can be, as I said, resource schema or a CRD. It will clone it into a separate API resource schema, and in case of CRDs, it will first convert it to resource schema and then store that. And that's basically it. And that's how replication virtual workspace can expose that cowboy type, because it knows that there is a backing resource schema.
So
And we would then expose that information in status of cached resource, and then the provider, when creating the API export, would look, well, they need two things, right? They need the identity hash, and then they would get the schema object from the cached resource status from here. Now, is that clear? Does that make sense?
It clears to me. I'm conscious it might be a bit of overkill for people who don't know this in depth. So I'm very cautious about time, and I kind of like the fact we're gonna keep the schema. In my head, this feature is quite advanced, and I'm very much willing to say, let's cut scope. And if this means the source is schema only, you always have to provide the schema, I think that's fine. And if this gets widely adopted as a feature, we can think of better UX and DX around that. But
yeah,
I don't see like option 1 and 2 doesn't sound right because of like the consequences of those.
Yeah, I agree. Just one issue with this approach is CRDs are mutable, API resource schemas are not. So once you create your CRD and create your cached resource, that behind the scenes will create an API resource schema from that CRD.
I would even go even further. I would say, like, don't allow created from CRDs. Like, make it API resource schema object has a single source of truth, and that's it.
Okay.
Meaning, so, if you're pointing it to some other, I know, like I don't even want to think about this pointing to some other resources. So now it's like one use case which basically allows us to solve one problem. Let's not dwell to like other realms of possibilities. The core source of information in KCP is API resource schema. Let's use that. We have already like CLI machinery to convert CRDs to API resource schemas and everything. And we just say like, yeah, use that. And once somebody plays with this, tries it, and wants to do something more funkier, we can discuss these cases.
Yeah, I agree. So that's one thing. And then still there is one more issue to discuss, but I don't, from API point of view, how API bindings are structured, I think it's fine. So, okay, let's imagine the scenario stays. So we have a virtual resource here. We have bound it to here. we want to get those resources, and underneath the cached resource schema in here, no, actually, sorry. It would be co-located with the cached resource. So in here, there would be a cached resource schema. Let me copy this maybe over. This has been deleted and recreated, and now we have the same issue as before. So our first we can have conflicts still, and in addition to that, the data that we have stored into cache might not correspond to this version of schema, because this might be coming from so the cowboys might be coming from CRT, but we have a cached resource schema that is referenced, a cached resource that is referencing a schema. So how do we prevent people from replacing a schema after they have bound that virtual resource? Like technically, the way to do that is
What's
easy.
the current behavior with API exports and API resource schema?
So the current behavior is the consumers will not be affected, because when you do the binding, the reconciler will first create a CRD under the
hidden
hood
CRD,
from the schema,
which basically,
which is a distinct copy of the original source, and that makes consumers completely unaware of any changes here. And this is a good thing, but I don't think we can reach the same level of self manage. How do you say? They are not so disconnected from their original source, because remember, those are virtual resources that are not local to the workspace. They are coming from another source, which I think should have that implication that the consumers could be affected, because their data is not coming from their own workspace, it's coming from an external source. So if that external source goes away, they will notice.
I'm very much, I would say, be pragmatic. Let's not solve this problem now. It's like, if they do something, it's a technology. People can do stupid things with technology, and it's a limitation. We can work around this in the longer run, I think.
For this specific use case, we have bound API resource, and then in the original bound API resource schema, we have UID. So if you replace the resource schema, this will not match. Currently, this is not used for this use case of checking that the schema is actually the one that existed during the binding. But we could use this to convey the information that the source resource schema, this one, has been replaced, and we can now probably stop serving.
I don't think we should stop serving, maybe give a warning. So I would say, again,
we can do a condition that there is a global informer on schemas in binding controller. So I think we can.
Look, I think let's not solve it. Let's document it in an issue, in a follow-up, and just like faster we can get this into the hands of users, faster we can get the feedback, We know a limitation now. You can't recreate those. You can't do the schema stuff. We know there is some other limitations with exports doing the similar things. Like how do you lifecycle APIs in general? It's a hard problem to solve. I think let's not solve it, else we're gonna never ship this stuff in the first place. So
Yeah.
just let's have an issue created, follow up. All this stuff is behind the feature flag, which is disabled by default. So, like,
Yeah. So this will be one topic, and the other maybe we can leave it for later. But there is this polymorphism feature that we are looking at, and virtual resources are a bit at the center of that, if I'm understanding that correctly. Do you know some details about that?
not yet. I think let's maybe take this one offline.
Okay.
I don't know enough to discuss it. Like how this. I know where the conversation is happening, but I don't know enough, and I would not want to tie this stuff now to this again, just because of said how long this been in the pipes.
Yeah. Cool. Yeah, I think we can keep it more simple than less, if we can. And
As I said, like it's a behind the flag. We can change it. We can move it, the things around. It's a bit more flexible.
yeah.
And having the schema requirement is like I like it very much because it just makes things way easier when you have a hard-coded schema available to
Exactly.
refer to.
Yeah.
Cool.
Thank you.
Thanks, man. It's I'm very much aware how deep these things go. So it's a hard conversations to have and a lot of context to absorb. Cool. And with this, I don't think we have any more agenda ones. I want to open the floor to other topics, other questions, if people have. Basically, for those who don't know, it's just basically, if you have any questions, it's place to ask.
Oh my word.
Hey there. Hi, everyone. Yeah, so I have a quick question. As I've been asking you over the Slack. So we now learn to without the API resource schema, we are trying to develop through the CDN that should be able to do the bindings. Is that Robert trying to explain today?
Not in a way. So the particular problem Robert is solving, imagine a situation, I said, you want to do a virtual machine as a service. So you create an API, like a cluster API or something, where you have kind machine, and people want to create VMs, like virtual machines. And you can have multiple sizes of those, like small, standard, with GPU, without GPU, like imagine cloud providers. You have gazillion of those.
Right. Yeah.
And those usually are represented by its own object, like kind instance type. So when you do what you do, you refer these objects to each other. You say, my virtual machine foo in a spec somewhere, spec machine type, with GPU standard D4 or something like that. So the challenge is when you have let's say 500 instance types and 500 consumers of the same API export, you basically need to copy paste 500 CRD objects into 500 consumers, which end up with an enormous amount of data into etcd, just because you're copying just a static data around the place, so people could refer it in a list, basically. So-
Okay.
So idea is that we introduce this virtual resources, which allows you to define in a single location, in a single workspace, these 500 instance types, and expose them like a proxy into every workspace where the binding exists. So people do kubectl get instance types, and they see all of them, but they can't modify them. They just see them in a read-only way. They can refer them as a metadata in the API, but that's it.
Yes.
So it's like a static list creation, like population in a way. So where is I can add where is the document? Virtual resources docs, original document we had about that. If you want to read it about it, let me find it in a second.
Sure. Thanks.
So I'm gonna paste it in a chat, and I'm gonna paste it in a meeting note. It's in general, I think the document already a bit older from what Robert showed, but that's because we kind of evolved as we go, and we didn't kept it up to date. But reality is, it kind of defines what's the plan and where we're working towards. What's the goal, basically?
Right. Thank you. I'll go through the doc. And I have another quick question, which I am trying to go research on the KCP docs. So my immediate question is that, so we have a, what do you say that? Yeah, so we have a controller and the controller that have been created a provider workspace and created two consumer workspaces, and through provider we have established the CRD, API export, and API resource schema. From the consumer workspaces we have did the API binding and then run the reconcile. So we're able to get that. So that part is good. So now we're getting on to the EKS cluster now. So we created EKS cluster. So onto the EKS cluster, we are trying to sync both of it. So if we do the changes, it has to be, it has to be in sync. It has to be shown onto the EKS cluster as well.
So those changes in a consumer workspace, or basically what the consumers create, they have to be synced into the EKS cluster.
That is correct. Yeah.
So you might have.
Sorry. So let me just do this. So I was going through the syncer, but they said that we do not use the syncer anymore.
Yeah.
It's not under maintenance. So instead, MDic has informed me that we are going through with the TMC if you want us to do that way, but I do not see anything with the TMC thing.
So okay, so let me. So TMC used to be this. I said it's a. Let me find the repository. Contrib. So I'm gonna paste it in a chat. So that's the repository. It's not being maintained for the last 2 years. I'm very cautious. Your use case might be very specific. If you could just maybe prepare some Xsolid draw diagram or like Google document explaining what you're trying to solve.
Okay.
And if it's proprietary, like you can engage with me or Marvin directly, like DMs. We can help you to solve it, to basically advise how to do that. I would prefer it to keep it public, like for the community in general to learn. But I totally understand that sometimes these things cannot.
Right.
So as much details you can provide, we can help you with that. The syncer, yes, it's deprecated. We have other ways to sync things around, and we're gonna have more ways to sync things around. because
Okay.
but I don't know what problem, like what actual thing you're trying to sync out. So I would need some documentation before that, something like that.
Okay. So basically sync all the this virtual workspaces, I mean, this workspaces to be, if you create so instant like, so basically we, for the EKS cluster, we set the kube config pointing out to the EKS cluster, and then we create by kubectl create workspace. If we sync it on this particular KCP side, it has to be automatically sync on to the EKS cluster.
Yeah, I don't have enough information. So like the workspace itself is not something you can sync into the cluster.
Right.
The content itself, like a translate the content, might. So it's I said, if you could document it in a way like
Yeah. Sure, I got it.
YAML examples, API examples, what you're trying to do, and what you're trying, I think that might be way, way easier. Another thing which I recommended, and I'm gonna poke it again, and so Robert and a few others of us, we did a workshop in KubeCon London. I pasted the link.
Oh, yes. Yeah.
If you didn't see that, I would strongly recommend just going through the workshop. You can do that offline, going through the content and trying that. I think it should give you a good understanding what you can and can't do.
Oh, okay.
But
Yeah, this makes
because
sense.
there is some of the older information from KCP from the days when it was under Red Hat umbrella, and we have a different agenda for that, and some of the things are deprecated. So I'm very cautious there might be some older material you're referring to. So again, if you could just draft a Google Doc, share it publicly or with me, Marvin, we can jump in a separate call and discuss your use case and how we basically can achieve that.
Yeah, we can do that. Yes,
Yeah.
absolutely. So because it's a little bit kept it on for a while, so maybe we can do a separate workshop. Maybe that should actually help.
Something like that. Like we very much think you're not the first one, you're not the last one, and it's like we're gonna we gladly help you as much as we can.
Yeah, this is mostly onto the internal side, so for the JPMC, so there has to be
And talk with your managers. Like I'm personally fine with, like, if it requires signing NDAs and things like that, I'm fine with that. So
no.
it's
Okay,
we
great.
try to keep it as much as in open, but again, it's a tough cookie to bite technologically wise. So we're gonna help you as much as we can.
Absolutely. And would you mind just sending us over any other ways of syncing stuff?
I will. Yeah, so another one. So we have this TCP dev. Wait a second. I'm gonna find the links. I'm pasting those in the document too.
Yes, please.
So we have a sync agent. So that's one of the ways to sync objects. And we've been working on a different project, KubeBind, which basically KubeBind itself, like it's in a meeting notes document. So these things, like how you could achieve this syncing. But again, it's very much depends what you're trying to do and what you're syncing.
Right,
Like, is it a whole state? Is it a specific objects? Do you need to do translation? Because imagine that the KCP enables you to do this many-to-one multiplexing, many consumers in a workspace to some API export to the single controller. But now you need to demultiplex it when you're hitting the AKS cluster again. So there is a mixed logic in there.
Right.
And that's why I'm saying, without understanding what the actual problem is, it's very hard to tell something.
Yeah, I might give you more description on this in some time. So maybe
Yep,
I'll
yep.
just
So-
bring you on in Slack again. But this API sync agent, that would definitely be a to go thing for us, for me to go
Yep,
see
yep,
on those, and then
yeah.
But yeah, thank you again, and thanks for everybody contributing on this. That should have definitely help us out today. Thanks for the session today.
Cool, no problem. I'm not sure how to pronounce your name. Oh, Olalekan? Like, do you have a question?
Yeah. You can call me Ola.
Okay, that's way easier.
Yeah. So I'm actually new here. I mean, I actually have a question regarding the virtualization, right? I mean, I'm trying to understand. Is it using KCP, one is able to spin up a virtual machine? Is that what it essentially means?
Not in a way. It's an example of one could do a service, because KCP in general is it's a framework to create control planes.
Mhm.
So when you're talking with Google API or Azure API, you're talking to Google control plane or Azure control plane.
Okay.
Like when you hit their API, their proprietary control plane responds to your APIs. So
Mhm.
Google Compute Engine or Azure VMs basically are just a microservice responsible for virtualization. So one could build something similar using KCP. You imagine your own APIs and what provisions those things under the hood. It's up to you. So that what Robert was talking and I think it's more like a hypothetical example of what one could be doing. But there is no virtualization involved, there is no compute involved. It's in general technology to manage APIs and consumers of those APIs.
Okay. Okay. So basically, KCP doesn't really know if it doesn't care if your VM or I mean if your machine even supports virtualization or not, but it only exposes the virtualization API for you to interact with your machine.
It's like it exposes any API. Like if you choose to create this API to create machines, like yes, it's basically in the old days we used to be. So I think we have a. Let me find it. So as you knew, so I would strongly recommend. In our Git repo, we have additional references of the talks we gave. So like if you look to the latest ones, like a first one and second one, you will find this YouTube talks recorded, which has quite a nice overview what you can do. And I think we have another one. I don't think we updated YouTube deep dive one. So if you ping me on Kubernetes Slack, I can send you the latest one where we did a deep dive. No, we don't have it here.
Okay.
But this one is, oh yeah, this one is the second one in the list. So I would say, without going into much details, the talk which Robert pasted in a chat, and if you watch that and you need more, let me know. Basically, I think that could give you a better understanding. It's yeah, it's just basically that.
Okay.
Cool. Any other questions?
Not really. I mean, I just want to chip this in. So it means if KCP, I know you guys don't support this yet. If KCP is able to undo like virtualization API, right? Correct me if my use of word is also wrong, right? If it's able to handle virtualization API like you displayed earlier, it means you could also do stuff like probably exposing something like a unikernel API, right? So if you don't want to run your workload using containers or pod, or VM, you could actually expose maybe a custom resource that understands how it is going to handle applications that are bundled into unikernels, right?
That's basically it. Like you can create your own API, and just it looks and feels like Kubernetes. It's CRDs, but under the hood you can run it on a Slurm, like a ML framework itself, or something else.
Okay.
It's like in the old days you used to have these API gateways. I don't want to mention names, but there's
Yeah.
quite a few vendors where you can literally write your own JSON APIs and just expose them. And what you do behind the scenes, like whatever.
Yeah.
So think of API gateway, just Kubernetes style, which works with kubectl.
All right, makes sense.
Cool.
Would I add to that is KCP is for cases where you want to model provider-consumer relationship in Kubernetes style. If that's an okay definition. So you have a provider, you have a platform owner, there is a service that can be used by consumers, by users, and if you have that kind of situation where you have many services and you want to fund them out to consumers, this is KCP may be useful to that.
Yeah.
Okay.
So same applies. The workshop in a chat, London workshop, I think it's one of the better materials we have at this point in time to give a holistic overview of what is what. So, and it works with a GitHub Workspaces or Google Cloud Shell. So if you could just follow README files and try it yourself. And if you have any questions, basically KCP users Slack channel in Kubernetes Slack is just ping us and we can help you.
Okay.
Cool. Okay, and we are top of the hour. I'm gonna say thank you all for attending and see you in 2 weeks.